Pure substance. What is a pure substance? The material with unchanging the chemical position. The three common phases of pure substance: liquid, vapor and solids. Also consider liquid vapor mixtures, which are a combination of liquid and vapor where the pressure and temperature are not independent. State postulates the two independent intensive properties are required to fix a state. Intensive independent of system size, usually per mass. Extensive depending on the size of system. Next one is a properties diagram for the phase change process. Understand what happens during the phase changes process. Display the relationship of properties on diagram: temperature, specific volume, pressure, specific volume, pressure and temperatures. These are the TV phase diagrams. The yellow color highlighted the solid liquids, subcooled liquids. Those are the supercritical states. The green colors highlighted and critical points mentioned in 1 point. Above the blue color highlighted. The phase 1. In on the bottom side, the solid plus gas vapor, the triple lines mentioned, the P in the low, the saturated vapor dome, liquid plus gases, the gases and superheated vapors. The saturation state, the phase translations. Next one is a TV phase diagrams. They mention the critical point. These are the compressed liquid regions. These are the superheated vapor regions. Then middle of the domes, the saturated liquid and vapor. The first line below the line, saturated lines. The P1 equal to constants and P2 equal to constant at less than the P1. Is the liquid line, saturated vapor lines. The T saturated superheated vapor, T saturated liquid vapors. Next one is the PV phase diagrams for compressed liquid regions. Saturated line, saturated vapor, saturated liquid vapor regions, superheated vapor regions. This point mentions the critical points. T2 equal to constant temperatures, T1 equal to constant temperatures. The mentioned the sublimations, two ways a substance can go from the solid to vapor. The liquid vapor, solid state, vapor and solid state. The melt to liquid, then the vaporized to vapor. Evaporates directly without the first melting. Sublimations happens at the pressures below the triple point value. These are the common properties. A set of the properties that completely describe the system, specify the state of system. M means mass, extensive, units kg, the volume V, the extensive, units meter cube, pressure intensive, absolute unit Pascal PA, gauge P gauge, temperatures absolute units Kelvin, the specific volume V, intensive, units meter cube per kg, V equal to 1 by density equal to V bar M, internal energy U, intensive, units kilojoule per kg, U equal to M into U, kilojoules. Next one is enthalpy H, intensive, units kilojoule per kg, H equal to U plus PV, H equal to U plus KPV, H equal to M into H. These are the common properties. The properties continues. The entropy S, intensive and extensive, enthalpy extensive kilojoule, intensive kilojoules, H equal to U plus PV minus H equal to U plus PV. The Gibbs function, extensive kilojoule, intensive kilojoule per kg mentioned. Next one is a saturated liquid vapor mixture, SLVM. The quality is a function of the horizontal distance on PV and TV diagram. A, B, C mentioned. H equal to M vapor, the mass of vapor, and M liquids, mass of liquids. M vapor, M liquid plus M vapors equal to mg, mf plus mg, mass of liquids. As shown, the saturated vapor mixture shown in the figures and derived here. The next one is a triple point line. The triple line or point, the area where all the three phases can exit. The line on PV and TV diagram, point on the TV diagrams. These are the pressure and temperature. Midpoint is called as a triple point line, the sublimation line. The solid state, vapor state, critical point. Substance that contact on freezing, substance that expand on freezing, that means the melting. Next one is PV T surfaces, the pressure, volume, temperature, surface present a great deal of information at the nodes at a once, but in the thermodynamic analysis it's a more convenient to work to with the two-dimensional diagrams such as the PV and TS diagrams. As shown in this pressure, solid state, liquid, critical, shown in the 3D methods, the vapor, liquid line, triple line, solid vapor, horizontal volumes, the temperatures is the pressures.